We're going to simplify this expression so that no negative exponents appear in the final result. I would start by moving that t to the fifth down to the denominator since it has a negative exponent. From there we can combine the t to the fifth and the t to the third. We get t to the eighth power. Now that whole fraction is still to the negative 2 power. So if I use that negative exponent to flip it over and square both the top and bottom at the same time, I would get a t to the 16th on top and a 25 on the bottom. So again, the negative exponent flips that, so the 5 would be on bottom, but it's going to be 5 squared, and the t to the 8th would be on top, but we square that, so the 8 times 2. Now that's still being multiplied by the 7 over t squared. Now the 7 and 25 can't reduce. The t's can though, so we get a t to the 14th on top. So that's what we're looking at for our answer on that one. For number 2 here, we would have to take the fourth power of the 3x squared y cubed. When we do that, we'd have 3 to the fourth power, which is 81. When we take x squared to the fourth power, we multiply those, so we get x to the 8th, and then y to the 12th, because we do 3 times 4. We just have the 9xy squared on the bottom. From there, we just divide the 2 out, so 81 divided by 9 is 9. X to the 8th over x to the first power, we subtract the 1 from the 8, we get x to the 7th. And y to the 12th over y to the 2nd, we subtract the 2 from the 12, we get y to the 10th. For number 3, we're looking to put this number in scientific notation. So we start by doing negative 2.4 times 10 to the, and it's a big number, so it has a positive exponent. And again, you can do the loops if you want, but what I look at is it's a 5-digit number. I moved the decimal place 4 times to get it behind the first number. So of 5 digits, I moved it 4 of the 5. So negative 2.4 times 10 to the 4th. For number 4, we're looking at putting the number in standard notation. Now this one has a negative exponent, so that tells me that it has as many zeros as that negative exponent. So 4 zeros, including the one that's in front of the decimal place. That one counts. And then we just do times 10. Oops, no, not that. We do. So then I have to put the 253 there, and then times 10. Okay. So there we go. 0.000253 in standard notation. For number 5, we just need to find f of negative 4. So we plug the negative 4 in for x. So f of negative 4 would be 3 times the negative 4 squared plus 7 times the negative 4 minus 4. So we just evaluate that. Squaring the negative 4 gives us 16. 7 times negative 24 would be negative 28, so minus 28 minus 4. 3 times 16 is 48. 48 minus 28 would be 20. 20 minus 4 is 16, so f of negative 4 is 16. For number 6, they're looking for us to find f plus g of x. So really we just add f of x and g of x together. So we'd have an x squared plus a 4x minus a 4 plus the negative 9x squared plus 10x plus the minus 2. Combining the x squareds, we get negative 8x squared. Combining the x's, we get 14x. And then the minus 4 and the minus 2 makes minus 6. So that's what we're looking at there, negative 8x squared plus 14x minus 6. For number 7, we're looking at f minus g of x. So again, the subtraction there important. That means that this g of x function, we have to switch the sign for each of those. That way we can actually add the two together. So we'll do the 4x minus the 3, and then since we're subtracting, we'll actually add the 7x squared, we'll add the 16x, and then subtract the 7. So again, just switching those signs so that we can add these together. highest degree term is the 7x squared plus the 20x, and then the minus 3 minus 7 gives us minus 10. For number 8, we're looking at evaluating the composition of functions g of f of 7. So what we can do first is we can find f of 7. So that would be 7 squared plus 4, so 49 plus 4, so we're talking 53. That's f of 7. So g of f of 7, so that's really g of 53. So we plug the 53 into function g. 2 times 53 is 106. Add the 6, we get 112. So that's really g of f of 7 is 112. For number 9, we're finding f of g of x. So we take f of x and we use g of x as the input. Of course, g of x is x squared minus 5. So if we plug that into the f of x, we have 2 times x squared minus 5 plus the 2. So 2x squared minus 10 plus the 2 gives us 2x squared minus 8. So that's f of g of x is 2x squared minus 8. For number 10, we're looking at finding the product. I've already set up a 2 by 4 box, so we just need to find the products for each cell and then combine like terms. So we will start with our 8y to the 4th, 6y to the 3rd, negative 10y squared, and 8y. And we also get 20y cubed, 15y squared, negative 25y, and 20. Again, notice we do have some like terms with the y cubes, the y squareds, and the y's. Our highest degree term, though, is the 8y to the 4th. Combining the y cubes, they're both positive, so 26y cubed. The y squareds, we got a negative 10 and a positive 15. So that's 5y squared, minus 25 and an 8. So we're talking minus 17y and then plus 20. For number 11, we're also finding the product. However, this is the sum and difference pattern, so all I need to do is square the 5r, which is 25r squared, minus the 8 squared and get 64. You could box or FOIL that as well. What you would find there is you'd get a minus 40r and a plus 40r that would cancel out. That's why we just have the 25r squared minus 64. Number 12 is squaring a binomial. So again, you can use the pattern. If you really want to, you could box or FOIL that out. But just squaring the first term, so 100 m squared. The second term, I put the two terms together, so 10m times 7 is 70m, and then we double that, so 140m, and then squaring the 7 gives us 49. So 100m squared plus 140m plus 49. For number 13, when you're dividing a polynomial by a monomial, all you need to do is to divide each term by the negative 3x to the 4th. So we set those up separately, then we just reduce those down. So 24 divided by 3 is 8. Of course, the negatives cancel out. You get an x squared because 6 is 2 more than 4. The second one, the negatives also cancel out. 9 divided by 3 is 3. The x to the 4ths cancel. And the third one, the negatives cancel again. 6 over 3 is 2. The x's end up on the bottom because x to the 4th is more than x squared. For number 14, we could use synthetic division as well, but I'll just go ahead and do the long division. Again, keeping track of my division over here, x squared divided by x gives me x. So I multiply that by the x plus 5. Gives me x squared plus 5x. So that's what I subtract. So subtract x squared, subtract 5x. I get 8x plus 38. So I continue with my process, divide 8x by x. This will be my last time through. See, we get For a remainder, we get 8x plus 40 here. Again, that's what we're subtracting, so subtract the 8x, subtract the 40. So you get a negative 2 for the remainder. And the way that we write that out is it's x plus 8 plus the remainder of negative 2 over the divisor x plus 5. And for the final question, number 15, synthetic division is not an option. We really need to do the long division. So we begin our process by dividing the negative 20x cubed by 5x. And we get negative 4x squared. So we multiply the negative 4x squared by the 5x minus 2. So we get a negative 20x cubed plus 8x squared. You notice the 5x and the minus 2, they're different signs. So when I'm adding the 20x cubed here, I would be subtracting the 8x squared here. So I get a minus 25x squared plus the 20x minus the 4. So we restart our process by dividing the negative 25x squared by 5x. It gives us negative 5x. So we multiply the negative 5x by the 5x minus 2. Gives us negative 25x squared plus 10x. And I'll really be adding the 25x squared, subtracting the 10x. So that gives me 10x minus 4 with what's left. We go through our process one more time, dividing the 10x by 5x to get 2. And then multiplying 2 by the 5x minus 2 gives us 10x minus 4. So I'm subtracting the 10x and adding the 4. So this one actually divides evenly for us. The answer then ends up being negative 4x squared minus 5x plus 2. Thanks for watching, and hopefully that helped.